Good morning, good afternoon, good evening, a bit depending from where you are joining us today. My name is Steven de Winter. I'm the Senior Director for Sales Engineering at Parallels, and I will be your technical host for today's session. I have a broad background in all kinds of IT, infrastructure, cloud, and user computing, so this is not going to be your typical marketing webinar from Parallels, but this is going to be a technical session in which I will go through some topics which we also typically cover during one of what we call our technical professional advanced training. So what we're going to discuss today is how RAS architecture looks like, but not only the simple ones, but also I'm going to go into details how you can, from those simple designs and those simple components, also build out a RAS environment or a Parallels RAS environment, which is like enterprise ready. So that means that we're going to discuss what makes an architecture enterprise ready. We're going to discuss concepts like multi-site deployments, multi-tenant scenarios. We're also going to have a look in how you can set the Parallels RAS covering multiple data centers, and then depending on certain scenarios, what is the most appropriate architecture decision. And then linked to these enterprise scenarios, we're also going to discuss some of the more advanced features like preferred routing, multi-hop architectures, and then also from a client point of view, like, okay, your backend and your infrastructure is then enterprise ready, but how can you deploy your clients also in an enterprise context? And we will have plenty of time at the end of the presentation today for a Q&A. So as you can see in this GoToWebinar, there is a possibility for questions and answers. This is a live webinar. So if you have like any questions, don't hesitate to put them preferably in the Q&A part of the GoToWebinar or in the chat. I will at the end of the presentation, I will have a look at the Q&A part and try to answer as many questions as possible. But let's start. So let's maybe start with a 1 minute quick recap of the Parallels architecture. So for those of you who are not super familiar with Parallels RAS, Parallels RAS has multiple components, and the main components or the key components is what we call the secure gateways and the connection brokers. So these are the mandatory components that you need in any infrastructure, in any design or in any implementation you do from Parallels RAS. The secure gateway is the component which is used for the clients to connect to, and the connection broker is, let's say, the brain of the systems, and it's a connection broker that then, for example, based on the user identification, then, for example, will list which applications or desktops or maybe even physical PCs that a certain user can connect to. Besides the secure gateways, if you can scale them out, we will see that later in today's session. You can have multiple secure gateways for scalability purpose. If you need to make your secure gateways also high available, we have a component called the HAL-B, or the high available load balancer. That's also a component that comes from Parallels that you can put in front of your gateways to make them high available. So typically, either you're using your own third-party load balancer. So, for example, if you're deploying on Azure or any of those cloud platforms, you can use an existing cloud load balancer from the hyperscaler. Or if you're deploying on premise, you can, for example, use the built-in high available load balancer from Parallels. From there, your users will then be load balanced to one of your secure gateways. On the secure gateways, you're connected them to the connection broker. The connection broker will do the identification, will list the applications and desktops which are available, and then the sessions can start. So this is the main concept and the main architecture components. Something important that Parallels also does is it has integration points into underlying hypervisors or cloud platforms. We call these providers. At the current time of this webinar, we have 7 providers. These are for on-premise Hyper-V, VMware, Nutanix, and scale computing. So if you're running in your own data center, you can integrate into these platforms and do things like auto scaling and power management. If you're using cloud deployments, we have the same functionality for Azure, Amazon EC2, and then also for Azure Virtual Desktop. So if you're using any of these platforms, Parallels Parallels Remote Application Server can also automate and scale out your environment. With these components recapped and rehearsed, let's have a look at what we would call like a typical simple architecture. And if you take a look at the single farm, single site architecture, that is a deployment or an architecture type where we can already make everything high available. So this is not something complicated for those of you who already have done Parallels installations. Whenever you start your installation, you typically start with deploying your primary connection broker. Once your primary connection broker is up and running, and it's basically like a next finish install, you activate either the built-in license or you activate it with your own license that you have purchased. Once you're in your primary connection broker via the Parallels console or via the management portal, from there you can do a full deployment of the other components. And as you can see, this is what we call a single site, single farm setup. We're going to discuss later on more advanced architectures, but let's say in a single site, single farm setup, it is perfectly possible to have all the components high available. So for example, what you can very easily do is, for example, deploy a secondary connection broker. And then whenever your primary connection broker, for example, needs to be rebooted or is down or is broken, the secondary connection broker can take over. Or for example, for scalability, if you're going above a certain amount of connections, you could have like multiple connection brokers to load balance the traffic. And there's the same story with the secure gateway. So we can have multiple gateways where then, for example, the high available load balancer is in front of it for making things high available. The high available load balancer, that's a virtual appliance. So for those of you who are not super familiar, all other components or software which is deployed on top of Windows servers. But the HAL B or the high available load balancer, that's a virtual appliance that you can spin up on your own infrastructure. Of course, for if you want to make things high available and you only have like one HAL B, then you still have like a single point of failure in your architecture, so you can have multiple ones. And then those can be made high available by adding a virtual IP. So you can assign a VIP that then load balances between those HAL Bs. So technically speaking, with your clients, you connect to a VIP, an IP address, a VIP IP address, which balances between your HAL B load balancers. Then that HAL B will pick any of the secure gateways and then connect you, for example, with your desktop or your session host in the backend. This scenario scales pretty well. We can easily go up to 5,000 concurrent users. That's not an issue. Of course, if you go to 5,000 concurrent users, you might need, for example, maybe like 4 or 5 or 6 secure gateways, and you might need like not 2 but 3 connection brokers. But it's a very simple and linear model where you can, by adding more gateways and more brokers, up to 5,000 concurrent users. Also, the 5,000 is not a hard limit. It's a sort of recommendation. You will see when we're discussing more advanced architectures later in this webinar. We're going to show, for example, how you can go to like a 10,000, 20,000, 50,000 concurrent user scenario. Another thing which is important in a single site is that the connectivity between the connection broker and the other components is fairly fast. What do we mean with fairly fast? That we see like a latency less than 50 milliseconds. So if you have 2 data centers and they are well connected, then typically that interconnection is less than 50 milliseconds. That's fine. You can set up like a single site across 2 data centers if you have, for example, a stretched network and that latency is good. But once the latency goes above that 50 milliseconds, you will see that we have other architectures that we would recommend. So 5,000, it's not a hard limit, but if you go above it, we should consider looking at making some modifications to the architecture, and the same thing with the latency of the network. Even in a single site, it is technically possible to do, for example, user segregation. So there is a concept which is called teams. You could, for example, create like multiple teams, and then you could say like customer 1 connects to team 1, customer 2 connects to team 2, customer 3 connects to team 3, and then you could give, for example, every customer like its own look and feel, it's their own policies, their own servers, their own applications. So there is an easy way to also segregate users into even a single farm. Very important, that is that in a single site and also in a single farm, it is also important to have all the components at the same version. And so that means that, for example, today, most customers will be like on version 22. We made version 21 available since yesterday. So if you go to the Parallels My account, you will see that that Parallels 21 is actually available. It's GA. It's general available since yesterday. We didn't send out the marketing emails yet. So for those of you who are joining me today during this live webinar, you get like a sort of scoop. Version 21 is GA. It's available for download in my Parallels. If, for example, you want to upgrade your existing environment to the new version, it is important that you upgrade all the components more or less at the same time. So that means that once your connection broker is updated to version 21, that you also upgrade pretty fast your secondary connection brokers, that you upgrade your gateways, and so on and so on. Important also to mention is that during the upgrade process, for example, of a single site, if, for example, you need to upgrade your connection brokers, that can be done without user impact. And if you need to upgrade your secure gateways, and these require typically also like a reboot, it is possible to do that. So you can, for example, upgrade your first secure gateway. At that time, users which are connected to your first secure gateway will be like prompted that the connection is dropped, and then after a few seconds they will be automatically reconnected to another secure gateway, and then you wait until the first secure gateway is back, and then you do the same for the second secure gateway. So there is a fairly simple process to upgrade everything to the new version in a single site. The only thing which is important is like that you don't put like days or weeks in between. That once you start with the upgrade, that you continue with the rest of the infrastructure at the same upgrade moment. Now, if we take a look at these limitations, for example, what if you want to go above a certain amount of users, or what if your network is not good, or what if you want to do like full isolation or full disaster recovery, then I think it's important that we take a look at some key considerations for let's say going like one step further into like enterprise designs. And it's not only about, for example, scalability, and scalability is something pretty obvious. If you go to 10,000 or if you go to 20,000 users, you have to make another architecture or design than if you deploy this for 20 or 50 users. But it also has to do with stability and with expectation management. For example, what if your company policy is that you have, for example, 2 data centers, and that you want to use like one data center active and the other one passive, or that your policy says that you need to upgrade first your one data center and then you can only touch your secondary data center, for example, 2 weeks later in another maintenance window. So these are all considerations that have to be taken into account when designing what we call these enterprise architectures. And one thing is key, and you will see that during today's presentation, that simplicity for me is very essential. So where possible, we will not try to make things more complicated than needed. Before we go into these multi-site and multi-tenant deployments and architectures, I think it's important to explain a few concepts and also take a look under the hood on how certain things work in Parallels. And this information I'm going to share is something you typically will not find in any public documentation. It's some of the internals, and I think it's worthwhile for these kinds of more advanced webinars to also give you some insights on how the product works under the hood. So there are basically 3 layers. We have the access layer, we have the logic layer, and the connectivity layer. The access layer is what we call like the secure gateways and the high available load balancers. Then the connection broker and the enrollment server is what we call the logic layer. And then the connectivity layer is the agents that run on, for example, the session host and the VDIs. The drawing next to it is a little bit misleading, because there is not such a thing as, for example, like a configuration a shared configuration database. Like some of our competitors have like a SQL database that is used to store the configuration settings. That is not how it works on Parallels. In RAS, what you will see is that the configuration itself is stored on the connection brokers itself. So each connection broker that you have has like a copy of the configuration, and it's actually there are some mechanisms in place that, for example, replicate these configurations to the other connection brokers. And this is also like a little bit explaining why certain ports need to be open, why certain considerations are to be done. And this will also explain later on when we're discussing like multiple scenarios on how, for example, we can do upgrades, or why a certain design is better than the other designs. So the first thing you need to know is that the primary connection broker of the first site has a special role. It is actually the one that has like a sort of like read-write access to the configuration. And whenever you make like a modification to a configuration, I think you remember that if you're like in the console, you have to click that apply button. Actually, it's on the moment you click that apply button that the primary connection broker will, via the redundancy service, push the configurations to the other connection brokers. And then, for example, once it's over there, those other connection brokers will then, for example, talk to the provider agent. And then the provider agent will, for example, start communicating with the VDIs or your session hosts or your systems that run your workloads. And so that's a bit how it works. So you make a modification on your primary connection broker, and then the connection broker will first replicate it to the controller service on the other connection brokers, and then from there it will talk, for example, to the provider agent if there needs to be like any communication with the other agents on the connectivity layer. If you take a look on the connectivity layer, we have multiple agents, for example, and it also makes a difference if you're using like templates or static hosts. So you will, for example, see if you're, for example, using static session hosts, that we're only using the RDSH agent. But for example, if you're using templated session hosts, that we're also going to use the guest agent. So the guest agent takes, for example, care of everything which has to do like with auto scaling and provisioning and templates and clones. And then, for example, the RDSH agent, that is, for example, then taking care for the specifics linked to the multi-user Windows operating systems like Server 22, Server 2025, and so on and so on. In a multi-site setup, and I'm going to explain what a multi-site setup is in the next slide. In a multi-site setup, it's also the primary connection broker of the primary site, so of the first site, that will first replicate the changes to the primary connection broker of the secondary sites, and then the primary connection broker of the secondary sites will do then the replication to the provider agents and the system. So that's also, I think, something important that you need to know how these things work. I'm not going into too much details on this one, but I think it's important to highlight that if for example, you're deploying Parallels RAS, that because of that replication system and because the fact that those connection brokers needs to communicate independently from each other, that there are like different network flows which are in use. So we have, of course, on one hand, the pure network flows which are linked to the user traffic, and that's then typically, for example, from the client through the DMZ to the secure gateways, for example, which is like typically 443 HTTPS traffic, and then from the secure gateways we go via the RDP protocol at 389 to the session hosts or to the VDIs, and so that's the, let's say, the traffic in gray on the top. But all these components also need to talk to each other, and these use other ports. So it's important that if you're making, for example, an architecture and a design, and you're working, for example, with multiple sites, and you have, for example, a site in your first data center and you have a site in your secondary data center, then it's, for example, also important that next to that user traffic, that also some of those communication flows and communication ports are open. And especially, for example, if you start integrating into these providers, These providers have like different ports. If, for example, like if you integrate into VMware or scale computing, just to pick two of them, it's based on 443 traffic. But for example, if you integrate into Hyper-V, it's another set of ports that need to be open. So if, for example, you have a host pool in your first data center, you have another host pool in your secondary data center, then make sure that all your connection brokers can, for example, talk to all these ports and all these providers when it comes to like designing your network schemes. Besides the single farm and single site, which we have discussed already before, one of the possibilities with Parallels RAS is in your same configuration. So in your same farm is to deploy a secondary site or a third site or a fourth site. So you can in a single farm deploy multiple sites. Why would you do that? That could be, for example, because you have, for example, multiple customers that you're hosting, and you want to isolate those customers on the site level. Or this could be that you have, for example, a site data center A and a site data center B. If you want to isolate certain resources like gateways, brokers from each other and make them completely isolated, introducing like an extra site is one of the possibilities that you could do. This could also, for example, help you scale above 5,000 concurrent users. You could, for example, create a site for your first set of users, and then create a secondary site for your second set of users. And then you could, for example, partition your users. You could, for example, say like these 3,000 users connect to that site. These other 3,000 users, for example, connect to the secondary site. Important is that all the sites run isolated from each other. So the gateways in a site only can access resources and connection brokers in the same site. What is important is if you're using like a single farm multi-site setup, and you have, for example, two sites, you're still consuming one license. What do I mean with that? It's still your primary connection broker in your first site that will be your license server, and that also means that, for example, if the same user, let's for example assume that your two sites are connected to the same Active Directory, and that as an admin you log into your first site and at the same time you log into your second site, that user will only be counted towards one license on the Parallels side. So that's I think something important to mention. And what is also possible between sites is replication of settings and applications. So we could, for example, when you publish like an application in your primary site, we could make automatically that it's also published in your secondary site. You see the asterisk next to the replication of sites. So we replicate a lot of settings, but for example, something we don't replicate is the host pools. So if, for example, you publish an application, it will be also published in your secondary site, but then you still need to link it to the host pool in your secondary site, because like host pools are typically concepts which are like isolated in a site. So you cannot link from one site to a host pool in another site. That's, for example, something that is not possible. Another thing which is also still linked with that concept of a single farm multi-site setup is that all your sites must run the same version of RAS, and that has to do with the previous slide where we mentioned that, for example, if you do like a configuration change, it will always be done on your primary connection broker of your primary site, and then that configuration change is replicated to your other sites. So having a single farm, with multiple sites will help you, for example, with the latency. It will help you with the 5,000 concurrent user limitation, but it will not help you, for example, if you need to have, for example, one data center on version 20.2 and upgrade your other data center to version 21. So if you want to go into these kinds of scenarios, then we have to look at multiple farms, and we need to set up multiple farms completely isolated from each other. And then we could, for example, use our API to replicate, or some scripts to replicate certain settings or certain configuration between the different farms. Important when you switch to multiple farms, you will also have like multiple primary. If you switch to multiple farms, you will have multiple primary sites, and if you have multiple primary sites, you will have a multiple primary connection broker in your first site. So that also means that you have multiple license servers. So if for some reason you end up having multiple sites in an multiple farms, then you will also need multiple licenses. And so you will, for example, need to chop your license into sub-licenses, or if you're a SPLA customer, you will have to create multiple sub-licenses in your SPLA subscription. A special form of multiple farms is what we call multiple tenants. So Parallels RAS has a concept which is called multi-tenant. And multi-tenant is a scenario where you have multiple farms, but where you can share the same access layer. So you could have a shared access layer in what we call a tenant broker. So all your connections go to a shared access layer, and then from that shared access layer, you could, for example, go to a tenant one, which could be like customer one in the customer's data center, and then maybe go to a tenant two in another data center, or maybe on Azure, or maybe in your own partner data center. So we can put multiple farms behind what we call the tenant broker, and then have a multi-tenant setup. What are the advantages of such a multi-tenant setup? One of them is cost savings. You could, for example, make a full high available access layer, and then have maybe like smaller customers hosted behind, maybe with a single server that access connection broker and session host. Maybe you have like hundreds of like 5 to 10 user customers. You don't want to have like separated gateways which are internet facing, separate connection brokers. You could, for example, make a scenario where you have like for each of your smaller customers like a dedicated connection broker session host, but then have like a multi-tenant setup, multi-tenant tenant broker for the access layer. Or if you want to have like only one IP address on the outside world, but have like multiple isolated environments on the inside world, that could be another reason why you want to set up these kinds of environments. So multi-tenant is something that comes also with Parallels RAS. You don't need a license on the tenant broker environment. So if you deploy the tenant broker environment, you don't need a license on that one, but you would then need multiple licenses on your different tenant farms that you put behind this tenant broker. Very practical. If you're not familiar with setting this tenant broker up, if you deploy Parallels RAS and you run the installer, you will probably recognize this screenshot on the left side. So if you want to deploy like a standard setup, or you want to install like a tenant that you can then later on integrate into the tenant broker, you go for the first option, Parallels RAS remote application server deployment, or the custom one. Very specifically, if you want to deploy the tenant broker, you have to go for that middle one, the Parallels RAS tenant broker deployment, and then it's like a next finish install. The tenant broker could, for example, be helpful if you want to go above 5,000 concurrent users. You could still have like one single entry point into your network, but then you could have like multiple tenants behind it that each cope with a certain part of the load. We already spoke about the licenses, so I'm not going to repeat it. So there's no license on the tenant broker, but if for example, the same user logs in at multiple sites at the same time, they will be counted for multiple license. It's also important that, and I'm going to show that on one of the next slides, the decision of which tenant is opened, or to which tenant the user is sent, is based on the host header of the connection. So if you want to have like multiple tenants behind the tenant broker, you only need one IP address, but you need different DNS names. So you need, for example, customer1.mycompany.com, customer2.mycompany.com, and then based if the customer connects, for example, to customer one, the gateway in the tenant broker will know that it needs to be redirected to that tenant, or if it connects to like customer two, that it needs to be redirected to the secondary tenant broker in this scenario. Also important, all the authentication happens on the connection broker and the tenants itself. So nothing happens on the tenant broker. So technically speaking, your tenant broker could be in a work group. It doesn't have to be a domain joint, or if you're like doing hosting for multiple customers, you don't need to have like complex scenarios where you have like forests and domain trusts and all these kinds of things. Everything can happen completely isolated from each other. So in a multi-tenant setup, we're sharing the access layer, but the other layers, the resource layer and the control layer, are completely isolated from each other. Another very practical point. So how do you then, okay, you have your tenant broker setup. So how do you then integrate those other tenants? You can integrate an existing environment. So if you already have like deployed the standard Parallels RAS environment, there are two ways that you can integrate that existing environment into the tenant broker. One way is with an invitation hash. So as an administrator on the tenant broker, you can create an extra tenant. You can specify everything. It will create a unique invitation hash. You send the invitation hash to your customer, or you log in yourself onto that customer environment. You go to join tenant broker, you type in the invitation hash, and that environment will automatically be integrated into the tenant broker. The other way it can work is with a shared secret key. So instead of like pre-configuring all the tenants that can join, you can also create like a sort of unique secret key, and then you go to your existing environment, and then you say like join, and you use that secret key, and then it will automatically register the farm into the tenant broker. So you don't need to prepare anything up front. It will automatically integrate it and put these farms together. Once a farm has been joined into a multi-tenant setup, you can also still disconnect it. So you can also disconnect it again from the tenant broker. And another thing which is important is like if you're joining a farm into a tenant broker, it's not needed anymore to have secure gateways in the tenant itself. It's because you're using the secure gateways from the shared tenant broker, but it's also not making it not possible. So you can still have, for example, also a secure gateway or multiple secure gateways in a tenant which is joined into a multi-tenant setup. Why would you, for example, want to do that? Maybe you're, I'm saying something like a service provider for a healthcare provider. You have a tenant broker setup. Your tenants run in the hospital itself. It might be interesting to have, for example, a local gateway so that local connections can connect to the local gateway, but users that coming from the internet have to pass your tenant broker gateways where you're adding, for example, third-party security services. So very simple to set it up. You deploy the tenant broker, and then you might already have existing environments that you can then join via those invitation hashes or via the shared secret key. Invitation hash can be used once, needs to be pre-configured. The secret key can be used as many times as before and doesn't need to be pre-configured. And if you then want to take a look how it works from a logical point of view, so for example, user 1 connects to tenant 1. The load balancer picks one of the secure gateways. The secure gateway talks with the connection broker in the tenant broker. It recognizes that tenant 1 needs to be redirected to farm 1. So what will happen? The gateway will loop all the traffic through this farm. The connection broker here will be used to do the user authentication, and then once the user is authenticated, he can then, for example, start applications. Things like teams are all managed on the tenant farm itself, and are made then automatically available through the gateways in the tenant broker. And so this is not something you have to worry about. These things are automatically replicated. Certificates, that's another thing. If you're using certificates, these certificates are managed onto the tenant broker setup. So either you upload the certificates over there, or you're using Let's Encrypt from the tenant broker to fetch for the certificates. But the certificates is one of the only things which is managed from the tenant broker itself. So if we combine everything together, then we end up with this kind of matrix where we have the 4 different architectures: a single farm, single site, single farm, multiple sites, multiple farms, or the tenant broker with multiple tenants. And then we have like certain criteria. if you go above 5,000 concurrent users, again, it's not a hard stop. It will not break on a single farm, but we generally recommend that you look at other scenarios, for example, in that case. Or for example, if you want to do like full disaster recovery, you can do that with a single site, single farm, but it's, for example, more recommended to use other setups for doing that. And let's take a few examples instead of going over the matrix. Let's just take a few examples. First example could, for example, be you have multiple data center and your customer wants to have like an active passive setup that can be activated in the case of a disaster recovery. One of the possible recommended scenarios, and of course you always have to take a look in every case, but one of the possible scenarios could be that for this kind of requirements, you do a single farm with multiple sites. So that means that you create a site data center 1, a site data center 2. You make sure that there is network in between. You make, for example, your primary data center your primary site. Your secondary data center is your disaster recovery site. One of the advantages of this kind of scenario is that, for example, whenever you publish an application in your primary site, it will automatically also be like published in your secondary site. So that will make sure that your configurations between your sites are more or less synchronized. Of course, you still have to link it to your pools, but that's something that can be maybe scripted or be done fairly automatic. And then what you could do is, for example, in the event of an incident, you could configure your client to either connect to a load balancer IP that you switch, or you could, for example, also configure your client to have like alternative or secondary connections. So you can, for example, configure your client saying like, this is my Parallels environment, this is the primary connection parameters, but you could, for example, also specify like a secondary connection. And if, for example, the primary connection is not available anymore, your client will be automatically redirected to your secondary connection, and that secondary connection could then point to your secondary site and allow the users to transparently connect to the secondary site, for example, in the event of a disaster. Important, and I'm going to repeat it again, that both sites need to be at the same RAS version. So if you upgrade your primary site, you need to upgrade your secondary site pretty soon after that, because there is a replication between the sites. Those settings and those parameters need to be the same. Let's have a look at the second example. Second example is, for example, 2 data centers, active, and there is a very good network in between. And let's assume for the ease of the exercise that it's less than 5,000 concurrent users. This could be, for example, a nice scenario where you don't make things more complicated than needed. You just deploy like a single site across the 2 data centers. You're putting some secure gateways in your first data center. You're putting some secure gateways in your second data center. You put some connection brokers in your first data center. You put some connection brokers in your second data center, and you let your network layer manage the public IP inflow. I'm assuming if you have these kinds of data centers, that you probably also have like mechanisms where you can route your traffic to one data center or route your traffic to another data center. So you can play, for example, with public IP addresses that not public IP addresses, but IP addresses that can jump from one data center to another in the unlikely event that there would be like a full disaster. One of the main advantages is that you don't need to do any changes, like you're using your data centers active. So that means that all configurations, everything is in use. You could, for example, use the auto scaling feature. If you're sending, for example, more traffic to the host pool in one data center, that it automatically scales up and takes. And for example, instead, if you have, for example, 5 servers in one data center, 5 servers in the other data center, another host pool, your primary data center goes down. All your traffic is rerouted to your secondary data center. You're hitting, for example, the 80% load on your host pool in your secondary data center. Then you could, for example, use the auto scaling and Parallels RAS to auto scale that pool up to a higher level to have more resources. And one of the advantages in this scenario is that you don't need to do any replication; that everything is done automatically. In this scenario, and also in the previous one, take into account, for example, that if your primary data center would be out for longer than 72 hours, that you will have to take some actions to, for example, promote another site or another connection broker to primary connection broker for licensing validity reasons. But besides that, it gives you like time to react, and it's only like within 72 hours that certain actions need to be taken. So it gives you like plenty of time to react. A third example is multiple data centers, but with not a shared network. For these kinds of scenarios, we would recommend to either go to like a multi-tenant setup or to a setup where you're having like two completely isolated farms. On the positive side, it would allow you to do, for example, upgrade of one site before upgrading the other site. And this is also something I didn't mention, but for example, in a multi-tenant setup, you can have like sites on or farms on different levels. So you can have like one farm which is connected to your multi-tenant environment on version 21, and you can have another farm at the same time on version 20. That's not a problem. On the negative side, you would need to take care of replication, as mentioned before. So you probably might need to do some scripting or some processes in place to make sure that your two sites are the same. And also from a license point of view, you will have two licenses. So typically, for example, if you're like an end customer and you have a 500 user license and you're doing like an active over two farms, you will probably have like split up your license into like 250. On the short term, there will be no issue because Parallels allows you to do like over subscription for a short time. So if all of a sudden your 500 users end up on your 250 user licensed environment, that's not going to be a problem. That will work. But if that situation remains there for a longer time, you will have to take some actions on your license and for example, recalibrate your license to have more licenses in your primary data center and then in your active data center, and then for example, less licenses in your data center which is offline. But also on the positive side, this is like a real true, let's say, redundancy. Besides architectures, there is also a few other concepts that I would like to cover in this advanced webinar. One of them is preferred routing. So what is preferred routing? Preferred routing is a feature in Parallels that allows you to pick a gateway based on the started resource. So let me explain it with an example. Let's say, for example, you have a hybrid deployment where you have certain resources running in your on-premise data center and you have some resources running in your cloud data center. Let's, for example, say Azure. You have a gateway in your data center. You have a gateway on Azure, and your customers connect randomly. So technically speaking, it could be, for example, that one of your customers connects to your gateway in your data center. And he needs to start, for example, a desktop which runs on Azure. What we could do on that desktop on Azure, we could add a preferred route on that desktop on Azure and say that if this resource is started, the preferred route for this desktop is to use the gateway on Azure and not the gateway in the data center. Because if you would do that, then all the traffic would need to go from Azure first to your gateway in your data center and then go to the outside world. So that would, for example, put quite a lot of stress on your network between, for example, your data center and your cloud. So preferred routing has nothing to do with which gateway the authentication is done, but it has everything to do with which gateway is used for starting applications. So very practical. If you want to set this up, you can go to any of your published applications or to a group of published applications. You can click on the routing tab, and then based on the routing tab, you can add preferred routes. These routes could be, for example, like half-day load balancers. These could be secure gateways, or these could be like custom entry points on your network. And maybe you have maybe you're running on cloud and you have like an availability set in Asia. You have another availability set or another gateway in Europe, it might make sense that for example, an Asian desktop is sent out via the gateway in Asia, and that you, for example, using like only the load balancer to do the correct routing. So you can play with all these objects, and then you can make a list and can say, for example, the preferred route is first this, then it's that, and then it's that. So if you take a look at the algorithm, and in this example, I have, for example, 4 custom entry points. I have, for example, an entry point in Germany and France and Spain and Italy. What will happen is, for example, you start an application. The application will check if there is a preferred route. If there is a preferred route, it will try. It will instruct the client to connect to the first gateway in that list. In this case, this will be Germany. If this is successful, then it will continue to use the traffic over that gateway. If it would not be successful, it will check if there is a secondary route. It will instruct the gateway to connect via the secondary route. If it's not successful, it will try the third one. It will try the fourth one. And at the end, if none of those routes would work, it would fall back to the default route that was used, for example, to log into Parallels RAS. So you cannot start an application if you have not been logged in. So there is at least one route which works. It doesn't have to be one of the routes in the preferred routing tab, but there is at least the route that was used to do, for example, the user authentication. So then in the last case, it will fall back to the original connection and use that one to start the application. So preferred routing could also be like one of those features to cope with like more complex data center scenarios where you have like data center A, data center B, and you don't want, for example, clients or data to go from data center A to data center B to go to the outside world. You want to keep all your data in the same data center. Then the preferred route is one of these features that can be used. And another enterprise feature is what we call multi-hop gateways. So what is this about? Some enterprise customers, for example, want to terminate all their traffic first in their DMZ, and then, as a matter of speaking, with a single firewall port, go to the internal networks. It is technically possible also to set up gateways in what we call forward mode. So if you have, for example, 2 gateways, you can go to your first gateway and change the mode from normal mode into forwarding mode. And then you could, for example, put that gateway in your DMZ network and then forward from your gateway in your DMZ network to your gateway in your internal network. Only open that one firewall port, and then it's the private secure gateway in the internal network that then will, for example, speak to the connection broker. It's also that one that, for example, will host the web portal. So all the logic is then done on that gateway and that connection broker inside. And the first gateway, which is in the multi-hop scenario, is pure there to terminate the traffic and to loop it inside the network. Also, for these more complex scenarios, there is no need for any extra licenses or any extra management tools. Everything can be managed from the centralized management portal. The last topic I want to quickly touch before I go to the Q&A part. This is on the client side. So from the RAS console, there are several ways that you could, for example, also pre-configure the clients. We see this very often in enterprise context that you want to allow users to, once the software is onto their device, that they don't need to configure themselves the connection settings or the client settings. We can via email or via DNS text records do some centralized management from the RAS console. But it's also technically possible to, for example, use like a third-party software distribution tool like Intune to install a Parallels client with pre-configured settings. And if you take a look, there are 2 kinds of settings. We have what we call client settings. Is the clipboard allowed? Do we allow printer redirection? Do we allow access to the local devices? This is also, for example, typically settings that you would configure with a policy in RAS. And I'm not covering that today in detail, but the client settings, you could have, like, for example, a first setting on the device, and then once the user is logged in, that as of then he will automatically download a policy, and then via the policies you can keep them up to date or alter them. And then there are also connection settings. That's, for example, like connect to production, connect to non-production, connect to customer 1, connect to customer 2. So the connection settings. If you want to pre-configure the client settings, you can run the client, you can make your own configuration, and then you can export your settings into like a 2xc file. And then there are some parameters that you can specify to MSIX when installing the client to use that pre-configured configuration file for using it. Or if you call the file 2x settings.2xc and you put that in the same folder as your client MSI, it will automatically also take these settings. So that's one way to pre-configure clients. The other thing that could be done, and that's then more specific towards those connection settings, and this is more important. For example, if you're talking about like shared devices, or computers where multiple users log in. Typically, you don't want to store their credentials onto these shared devices. Maybe this is a device in a hospital where the morning shift has ended and the second shift starts. Then you're using the same device, but you don't want to use, of course, the same credentials. There is a possibility that once you have made your configuration, that you're exporting your connection settings, and you can do that again with MSIX, and then you're using the shared device parameter. And then there is a little trick, and I don't have a lot of time to go into details, but you can specify 0, 1, or 2. If you specify 0, it will automatically wipe everything. If you specify 1, it will only export the connection settings, but not the username and the passwords. And if you do set it to 2, it will also store the connection details, so including the username and the password. And then once you have that file, you can do, of course, the opposite. You can then, for example, automatically deploy a RAS client with the shared device setting, and then, for example, say like 1 import and your file, and then it will import those configuration settings without importing the username and the password. If you want to see it in action, there is a YouTube video on our tech bytes. I'm showing you the tech bytes also later on. But this is also like a nice thing which could be super interesting in an enterprise context on how to pre-configure your device settings. And then, of course, last but not least, you can, of course, also combine the client settings with the shared device settings. So you can combine these parameters all together. So that's also technically possible. Which brings me to the end of this technical webinar. This is actually one of the first times we do these kinds of pretty advanced technical webinars. So let me check if there are any questions. Let me open the Q&A part, and let's quickly look if there are any questions that came in. If there would be any questions, don't be shy. Just ask. So there is a question. The question is, if we have 2 farms, does each farm consume different licenses? We are, and I cannot read the rest of the question. Yes. So if you have 2 farms, you will always have 2 licenses. Of course, the Parallels licensing is based on concurrent users. So I cannot read the full question. But if you're migrating from one farm to another, let's assume that the users are not logged in at the same time. So they will typically not come twice at the same moment. I don't know your specific scenario, but feel free to reach out. We can get into contact and see how we can help each other. Let me see. There is a question. We are not yet a customer, but planning on trying Parallels in 2026. Thank you for that. So my question might be premature. Is it possible to expand a single farm, single site to a single farm multi-site? Yes, that's perfectly possible. So you can add or delete sites at any time. there is that's not an issue. You can start actually when you deploy your primary connection broker, it will automatically set up as a single site, single farm, and then you can add a secondary site, a third site, a fourth site. You might, for example, then delete your secondary site because you don't need it anymore. So it is technically possible to alter from a single site to a multiple site. Let me double check if there are any other questions. I don't see any new questions coming in. I would say don't be shy if there are like any questions. Please feel free to let us know. Reach out. There is my email address on the slide. So if you prefer to ask it private, just send it to me. I'll either try to reply myself or get you into contact with any of our colleagues that could help you with this. But with that said, and let me quickly check last time if any new questions came in. I don't believe so. So with no new questions in and almost at the time, I've seen that there was a lot of people in this webinar. So I want to thank all of you for joining. If you like the webinar, let us know. If you have like any suggestions for other webinars into this kind of style, let us know. We're considering webinars also on, for example, single sign-on and some of the other more advanced functionalities into RAS. So please let us know. Tell us what we did well. Tell us what we can do better. And for those of you who are at the end of your day, have a nice evening. For those of you joining from US or more west of me, have a nice rest of the day, and thank you for being here.